All right, welcome everybody. Exercise 1 for Lab 11, Geometrical Optics. What you see before, this is me, I'm waving my hand in front of the lens. We've got a lens. It is 75 millimeter convex lens. This is a convex lens. That means it's curved outward. And the light from my yard is going through it and forming an image on the screen right here. And you can see my arm moving around, and here's my thing. If I move it in front of the lens, you can see that it ends up on the mirror. And actually, the yard, I don't know if you can see it, but there's a tree and there's a sky. Do you notice how the sky looks like it's at the bottom of, the sky looks like it's down here, and you can see some clouds, and this is a tree, and this is a car, and this is the top of the car. So it looks like everything is upside down. So, let's actually look to see how I have this arranged. I've got the lens sitting at exactly 30 centimeter mark. This is an optical table, and it's got a centimeter marking on there. And what I've done is I've moved this back and forth until you get a clear image. Notice if I put it too close, the image is fuzzy. Move it too far away, the image also gets fuzzy. So let's see if I can try and make it as least fuzzy as possible, which is, of course, kind of hard to do, but all right, that's about right. So you can see my car in the tree. So let's look to see what the distance is between these two. So one of them's at 30. So what I've done is you got to measure from the middle of the lens. So I've set it so that the middle of the lens is at 30, and this one is at, looks like 23.2-ish. So the focal point of this lens would be 30 minus 23.2. So you can write that down in your data table. So that's our experimental version of it. Now the actual focal length of this lens is 7.5 millimeters. So now I'm going to do is set up the next lens, and I'm going to do that by just pulling this lens off, and notice the image disappears, and then I'm going to put the other convex lens in there, and I'm also going to stick it at 30 like I did before. All right, now we can't see any image, so let me see if I can move it until, oh, there it is. All right, might be a little harder for you to see because it's going to be a little dimmer and you can't see the light, but you can see down at the bottom. You can see some of the light here in the car. Do you see the car right there? It's blurry. I can't see the car, and then I can see the car. So let me move in a little bit so you can see that the image is still there. It's just a little bit dimmer. All right, so there's my second reading. So I've got this one, the lens still set at 30. So the screen now is at 15.8 centimeters. It's my best guess. So now we have 30 minus 15.8 centimeters. And this lens is 150 millimeters or 15 centimeters. So this should be 15 centimeters approximately. It's a little difficult to get the exact position where the image is not fuzzy. So there's a little bit of wiggle room on the measured value. The actual value is 150 or 15 centimeters, 150 millimeters, 15 centimeters. Okay, now we're going to go and investigate one lens, but we're going to look at the thin lens law.